Hello mates, welcome to my channel, and today I'm going to show you how to do factoring, and we're going to factor expressions. Now just because I'm doing this video doesn't mean that I'll be doing all videos like that all the time. It just means that I decided to do an educational video this time. That does not mean I'll be doing educational videos all the time. Anyway, so as you can see, expressions do not, I repeat, do not have equal signs. No equal signs. No. No, 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 and no. So, let's just take a look at this problem here. We have x squared plus 16x plus 63. Now we need to see, now we need to see what multiples of 63, when they're added, will give us 16x. So what multiples does 63 have? It's, 63 and 1. And I think the only one is 7 and 9. Just those two. I think. Anyways, so let's just use 7 and 9 because they're closer in the number 9, and that does not mean that every time, in every solution, you'll have numbers that are close in the number line as these multiples right here, as these numbers, but still, it's a good place to start. So, since we only have x squared, it's just x multiplied by x, no denominator or anything else there. Now, does 9 plus 7, does it equal 16? You bet it does, so plus 7 plus 9. Okay, now let's check this out. Does 7x plus 9x does it equal 16x? It does. So this is your solution right here. This is your answer. X plus 7 times x plus 9. This is the solution. And we cannot simplify it any further because we don't have anything that it will be equal to. Now let's take a look at the second one. Also, I forgot to mention, see this plus right here? The way I like to think about it is that plus is good. Plus is honest, man. Plus will never cheat. Plus will never play you. So it will always make these two signs the same. And this one will determine what those signs will be. So in this case, they are both pluses. Now, minus, on the other hand, does not do that. It will deceive you. It's bad. It's a bad guy. So it will make one plus and one minus. It will not make same signs. So 4x squared plus x squared, plus 4x minus 32. Now it's again just x, so just put it in there. Put the x in there. Now, what multiples of 32 when they're added will give you positive 4? So it's 32 and 2, 16, and 2, and 8, and 4. That was a bad 8, sorry. Let's just use 8 and 4. But here's the problem. Since we have a positive and a negative, which one should we make positive and negative? So when they're added, it's when those multiples were added, they equaled 4x, positive 4x, and the only way that can happen is if the positive number is bigger than the negative one. So we need to make 8 positive and 4 negative. Does 8x minus 4x does equal 4x? It does equal 4x. So is your answer right here? Let's clear this all out. Boom! Obliterated everything with this bomb. Let's take a look at this one. 9x squared plus 12x plus 4. Now this one's a bit tricky. Now we have some kind of denominator, but there is no common denominator in these ones. You can't just divide it by 2 or anything. No, you cannot. So don't even think about it. We'll just have to deal with what we've got. So the question right here is when do multiples of 9 and multiples of 4, when they're added, when do they equal 12? So what are the multiples of 9? 3 and 3 and 9 and 1. And what about the multiples of 4? Well, it's just 4 and 1 and 2 times 2. Again, I'm using 2 times 2 and 3 times 3 just because they're closer. And it might not be correct, but still, it's a good start. So 3x and again this is plus both signs, and these are both pluses, so plus 2 and 2. Does 3 times 2 doesn't equal 6? Doesn't it equal 6x? And this 3 times 2 doesn't equal 6x? And when you add them, doesn't it equal 12x? Huh? Yes, it does. It does. Believe it or not, it does. So, let's look at another problem here. 18x squared minus 9x. Wait a minute, where'd the third number go? How am I supposed to solve this one? Well, you know, just because it's not 3 numbers doesn't mean you can't factor it. Factoring doesn't have to be like that necessarily. Just by dividing it by the common denominator, it's still factoring. So what do 18x squared and 9x have in common? Huh? That's right, 9x divided by 9x. So we're left with 9x times 2x because 18 divided by 9 is 2, and there's still one x left, so minus 1. Can we break it down any further? No, we cannot, because we do not have an equal sign here or anything. So this is your answer here. And you can check it by multiplying everything by 9x, and everything will come back together. Let's clear this out. Now let's look at this problem. Oops. Ten x squared plus 3x plus 5. Okay, so which multiples does 5 have? That's 5 and 1, and that's it. Which multiples does 10 have? 10 and 1 and 5 and 2. Let's say we have 5x 2x. No, wait a minute. So you're saying if I substitute 1 right here and I don't know 5 right here, that's 10x plus 5, that's 15x. What are you talking about, man? That's not the right answer. So erase this one. Erase it. Good. And if I put in, I don't know, 10x and x, I don't know, then I put in 1 and 5, that still does not give me the answer. Ladies and gentlemen, you have just stumbled upon another type of equation, unfactorable, because, and I don't see any reason why you would substitute 5 in here, because 10 times 5 is 50 minus what? 1x, so that gives you what? 49. That does not factor, so that is not factorable, unfactorable. You can't even divide it by the common denominator, because, well, it's 3. It's not divided by, you can't divide it by 5, and you can't divide 5 by 3, because you'll get some really long decimal. So unfactorable. That was a bad A, whatever. You can see that it's an A, right? Bull. And if in case you ever come across a problem like that, write unfactorable. Clears out. What about this one? 16x squared minus 25. Huh, where did the third number go? What are you talking about, man? This cannot be factored. And besides, didn't we already look at this kind of problem? No, we did not, because this has squared in it. And it's not infactorable either because like look, this is a perfect square. 16 and 25, they're both perfect squares. So what multiples does 16 have? It's 16 1 and 4 times 4 times 5 times 5 25 times 1. So these are the multiples for the 16, and these are for the 25. So let's just substitute these in. So I'll just start with 4 and 4. 4 x times 4 x. Now you see, this is one that's deceptive, so plus and minus. Now we need to see, well, what multiples of 25, when they're added, was negative 25, when they're added, which multiples will give you 0 x? Will give you 0x, because just because it's blank doesn't mean that nothing's there. It's just you can basically substitute in 0x. Which ones will give me 0x? Probably 5 and 5. But don't take my word for it, let's just check it. 5 times 4 is 20, and negative 5 times 4 is negative 20. 20 minus 20 gives you 0. Problem solved. Okay, so I think that pretty much covers all of the problems. If I missed any, please be sure to comment, or you can just watch other videos, I guess. Oh well, till next time, this has been Peter here. I'll see ya.